All right, we're back. Let's take a look now at another example. This is example 2 from page 366. By the way, we're not doing this whole section 5.3 today. It actually starts getting to be a little bit technical and detailed after a while. So instead, we're going to come back to it on the next time we meet. But for now, I want to talk about some more of these simpler problems. Let's look at find all the solutions, find all the solutions in the domain or interval from 0 to 2 pi of the simple equation here. Well, I mean, simple, it looks horrible. Sine of x plus the square root of 2 equals negative sine of x. Well, let's think about the techniques that we're supposed to be using here. We're supposed to be taking a look at this here and trying to isolate the trig function on one side of the equation, everything else on the other. So let's pull that sine x over to the other side. And sine x plus sine x is just 2 sine x. Leaves a 0 over there on the right-hand side. And let's pull that negative 2 over to the other side. That's just, algebra again. We're just adding negative 2 to both sides of the equation. So now we have 2 sine x equals negative the square root of 2. All right, we're pretty close to the right way here. Now we can just take that and divide by 2 on both sides, and we have that the sine of x is equal to negative the square root of 2 over 2. Okay, that looks like we're getting pretty close to the answer. Again, well, you'd have part of the solution here if you then used your calculator and just took inverse sine of both sides. You would just get x equals the inverse sine of negative square root of 2 over 2. Okay, that would be a way of doing it. For today, I'd kind of prefer that you did it using the unit circle. Again, we're going to be looking for places where the sine of x is negative square root of 2 over 2. So we remember those coordinates that it's pointing at. The first one is cosine, the second one is sine. So if I go around here and I pick through here and I'm looking for places where the sine of x is negative square root of 2 over 2, I see it happens 2 different places. It seems to happen at 5 pi over 4, and it seems to happen at 7 pi over 4. Again, later, we're going to have to identify this whole business, not today. Later, we're going to have to identify that there's a pattern here. Like, not only would 5 pi over 4 work, but we could go all the way around the circle and back to 5 pi over 4, which would be 13 pi over 4, I believe. And so would, if I put 21 pi over 4. But we're not doing that. Let's just find the ones that are in this interval that it gives us in the problem here, 0 to 2 pi. And then so we found them. Okay, this doesn't seem so terrible. We're going to be relying on our friend, the unit circle. And just because it's good practice, let's actually check one of our answers here. Let's take the answer that x was equal to 5 pi over 4. All right, well then if this worked, this 2 sides of the equation in here in yellow, they should still be the same thing. So let's put 5 pi over 4 in for x on both sides and say, I wonder if that does actually match. Well, on the left-hand side, the sine of 5 pi over 4 is is negative square root of 2 over 2. Over there on the right-hand side of the equation, where it's minus the sine of this, well, minus, what is the sine of it? Negative square root of 2 over 2. All right, with a little simplification here of the signs, we see that both sides of this are actually square root of 2 over 2. Hey, it did match up. So our value that we plugged in there worked. And in fact, we could have done the same thing with 7 pi over 4, and we would have gotten it that it worked as well. Fantastic. Let's try another example. This is example 3 from page 366. Oh gosh, it's got a tangent and it's got a square. This looks like this would be terrible. Well, let's just attack it. Tiny little pieces here. Let's start with that basic equation that we've got right there. And remember, our strategy is to isolate the trig function to be on one side. All right, well, if that wasn't tangent squared of x, but was rather x squared, we would know what to do. We would pull the 1 over to the other side to get it out of the way. That 3 out there in front looks kind of ugly. Let's divide through by 3. So we've got tangent squared equals 1 over 3. All right, well, if it was anything else squared, we would know what to do. We would just take the square root of both sides. So we'll just take the square root of both sides and we get the tangent of x is equal to, well, got to remember that plus or minus. That's always the tricky part to remember. 1 over square root of 3. We hate 1 over square root of 3. Let's put square root of 3 over 3. By simplifying a little bit. All right, time to pull out the old unit circle here.